All right, so we're just going over some homeworks. This is number 18, is that right? On page, what, 598? Okay. Just in case you're watching, you wonder where this comes from. All right, well, let's do this. Let's draw a little x and y axis, actually a rather large x and y axis. We'll plot the points. 10, 5. 1, 2, 3. And then 5. All right. And then 4, 2. Okay, I got enough. So it's all in the first quadrant, isn't it? All right, let's just change. How about orange? That'd be pretty. 10, 5, right? Which would be about right there. And then 4, 2. 1, 2, 3, 4, 2, which would be about right here. And this is C, and this is D, correct? And you're going, now watch, look at the vector. It's very important that you go the direction. What's that? Oh, it is. My bad, sorry. Right, this is C and this is D. That definitely makes a difference, doesn't it? Because you're going from C towards D. You follow me? Okay, it really is important that you look at that right there. So you're starting at C and you're going to D. Because the direction is half of the problem, isn't it? So that's what you're trying to find. You're trying to find how long it is, and the length of it's easy, right? It's Pythagorean theorem. I mean, it's distance formula, which basically is Pythagorean theorem. Is everybody okay on that? I don't want to waste my time going through that. Just take these 2 points right here, do the Pythagorean theorem, or keep saying Pythagorean distance formula. Keep saying Pythagorean. It technically is a Pythagorean theorem, though, isn't it? Because you go like this, go like this. You can do Pythagorean theorem, but it's a distance formula. So it might help actually to I'll keep it orange, to actually draw it out. So to there and to there, right? And what are the lengths from here to here? This goes from what, 5 to 2, so that's 3, isn't it? And this goes from what? From 10 to 4. Did I do that right? Yeah, from 10 to 4, that would be 6. So that helps a little bit with the angle, because we need to know those sides, don't we? So what are we trying to do? We are trying to find the angle. Now, what is the angle? This is where you're starting, correct? But you're going in this direction right here. So what we're going to have to do, and this is the part that is a little bit tricky. You're going to have to put another XY axis up here. Okay? Pretend this is the origin of our new X and Y axis. That's the part that messes people up. Remember doing that? So if I put an x-axis here, x-axis, or y-axis, then an x-axis. So think of it like this. Think of this as being a brand new x and y axis. And where's this coming from? You start where? You start at the positive x-axis. They call that standard position. Okay, you start here, and you got to go to there. Because you always start. Listen to what I just said. I said you always start at the positive x-axis. Okay? So this would be, if I draw my x and y axis, that's the x-axis, that's the y-axis. Where do I start? I always start at the positive y-axis, and then you go which direction? Counterclockwise until you hit your line, until you hit your vector.
So you already know it's over 180.
Yeah, you know it's more than 180, exactly. So this from here to here would be 180, so all you got to do is basically find that angle right there, don't you? Okay, which is the same as what? This angle right there, isn't it? Okay. Or you could do this, or you could find this angle up here, right? Take it away from 90 to get that angle, right? Just trying to think of the best way to do this, the most consistent way. Let's do it this way. No, it doesn't make any difference, because I could still go, yeah. What do you want to do? Do you want to find this angle right here? Or do you want to find this one? This one down here? Because usually when I do these, I usually find this angle up top here. It really wouldn't make any difference, though. Let's go that way. Is that all right? I'll just show you. Watch. We're gonna find. Let's get rid of this C. C's in my way. Let's put the 3 on the outside. Give myself some room, because it's the length from here to here. This is at 5. This is 2, so that's the length. That's 3. This is at 10. This is at 4. So 10 minus 4 is 6. That's that length right there. What's that?
If we did it the other way, the bottom one would just go 3 divided by 6. And then
Exactly. Exactly. Yeah, and okay, let's just go that way then. That makes sense. Let's just do it that way. All right, saves you a step. So let's find this angle, because this angle and this angle are the same exact angle, aren't they? All right, so what are we going to use? We got opposite, we got adjacent, so use the tangent. So use the tangent, we'll call that theta. The tangent of theta equals opposite over adjacent, and you just plug that in, right? 3 over 6 is 1/2, right? Now to solve for theta, what do we have to do though? Take the what? Inverse tangent of 3 over 6. So it would be second function tangent of 3 over 6. Oops. I need to save it with this in degrees. Let's try it one more time. Second function tangent, 3 over 6. There we go. 26.6, right? Is that my answer, though? No, it's not my answer because that's just this angle, right, which is this angle right here. So what do I have to do? I got to go from here to here is 180 plus that little bit, right, which is the 26.6. So you just add it to 180, and then that's your answer. Okay, and that's what? 2, that's a 10, that's a 0, 206.6, that sounds familiar. And that is your angle, 206.6. So from here to here is 206.6 degrees. Okay? And then, what do you mean, which numbers to use? Because it's opposite over adjacent. I use this angle right here. This is opposite of this angle. This is adjacent to this angle. So that's why I had to use that. Now, if I wanted to use this angle up here, let's do that in a different color. No, but it does matter how you set it up, though. If I use this angle right here, what would I have to do? I've got, well, you got to find the angle first. So what would I use? This is opposite this angle. This is adjacent to this angle. So I would use what? The tangent of this angle, we'll just call it angle A, right, equals what? 6 over 3, right?
You get the 3 over 6 because that's what the difference is.
Well, let's...
4 minus 10 is
Yeah,
negative.
right.
And then you just
And then let's put that in the calculator and let's see what we get. Are we still going to get that 26.6 for this? No, because watch, second function tangent of 6 over 3, you know that's 2, but I'll put 6 over 3 there anyway. And that's at 63.4. So angle A is 63.4 degrees. That's this angle right here, isn't it? Now here's a couple ways you could do it. Watch. Since this angle, we'll make this yellow. Since that angle right there is 63.4, you could take it away from 90 to get this, and that would be your 26.6. Then you add it to the 180. Or, that's like 2 steps. Or you could just do this. Watch. From here, from here all the way to there is how many degrees? 270. And then what would you do with that 63.4? Just subtract it. So it would be the same as the other way. The other way, we just took 26.6 and added it to 180, correct? This way, we took the 270 and we subtracted 63.4 from it. It's the same amount of work. It just depends on which one you would like to do. For some reason, when I always do these, I always find that angle that's attached to the origin right there, just to be consistent. Okay, does that make sense? But you did realize you are trying to find that angle, right? And this angle are equal to each other, so you could have just found this one. That would be fine. And there is another reason. I'm not even going to get into it right now, but there is a reason why I do this. Again, it's for a level of consistency. That's good enough. Okay. Alex, did you have a question? I saw you raising. Okay. Yes.
Well, if you have a problem like number 14, so your line goes side to side, well, what if the arrow goes like on J instead of K?
I don't know. I have to see the thing.
Still be
Let's do one of those where it comes out to be, not slanted.
you do 15.
Let's do 15 since everybody was asking about 15. All right. You find an AB, right? And A is 9, -2. And B is what? 9, -8? That tells me something right away. I see the 2 9s there, don't you? Alright, so let's do that. There's my x and y axis. Let's plot the points. 9, -2. 1, 2, 3, 4, 6, 7, 8, 9. Negative 2 would be right there. 9, negative 8, 2, 3, 4, 5, 6, 7, 8 would be down here. And this is the A, and this is the B, correct? And I start at A and I go to B, correct? Oops, I was close. Not really. I'll fix that in a second. So we'll say the dot is right there. I didn't eyeball it very well, did I? All right, so there it is. Now, right away, I can see the 9 and the 9, so it's a vertical line. In which direction is it going? It's going, this is 0 degrees, right? This would be what? 90 degrees. This would be 180, and this would be what? 270. So which direction is this going? It's going 270 degrees. I don't even have to go through any trig, because I can't even make a triangle out of this, can I? Right? I can't even make a triangle because it's a straight line, right? I hate to say a straight line, but it's a vertical line, so I can't make a triangle out of it. So I don't even have to go through any of that stuff. What about the distance? Do I have to go through the whole entire distance formula here? Not really, because look, where am I right here? I'm at negative 2 here. I'm at negative 8 right here, right? So what do? I just subtract. How far is it from negative 2 to negative 8? It's just 6, right? And then what's the direction? 270 degrees. So if it's something like that, it's actually pretty easy, isn't it? Because you got to look at the direction that it's going. It's going in this direction. Okay, look what I wrote up here. I put 0, 90, 180, 270. Which direction is it heading? It's going in the 270 degree direction.
Well, if it was going from B to A, would it be 90?
Then it would be 90 degrees, exactly. If it said BA instead of AB, it would be 90 degrees. Everybody see that? So that's not so bad now, is it? You want to do one of the other ones, like at a regular angle? I mean, not a... Let's do number 19 just for fun, just real quick, okay? Is that all right? Just to give us that little extra practice. You're only going to have one problem like this on the test, okay? You'll have one. But it's broken down into two problems. The first question is the magnitude, and the second question... Wait a minute. Let me just double check on that, because I think... I don't know if I changed that or not. Yeah, it is. The first question is the magnitude, like number 19. It's the last two problems on the test. Number 19 says what is the magnitude of the vector, and number 20 says what is the direction of the vector. So you can still get the magnitude and get one problem right. Okay, so that's nice, right? So you don't have to get them both to get the problem right. So it's actually two problems, but I split it up in the magnitude and direction. All right.
Is there going to be a problem that's like the one that we all had trouble on that one time and we figured it out?
Oh, you gotta be more specific than
The one
that.
where it's like the angle of elevation.
Yeah, the angle of elevation.
Oh,
and
God.
You know, I don't think I put one on there. You remember with the real hard one where we did the tangent? We put the y in there and then the x. I don't think I put that on there.
Like the one where it's like eyesight and
Thank you.
Now there are some word problems on there where you do, but I'm pretty sure I'll have to double check on it. But I don't think there's one.
Where it took like 15 minutes or the whole class period to figure it
Yeah,
out.
I think I put ones on there that were a little bit easier. I think that are easier than that one. So remember the one with the, well, easier. All right, let's do this one real quick. X is 6, 7, and Y is 9, 11. Tell you what, let's just scooch this out of the way a little bit, like up here. Actually, that's going to be in the way, isn't it? It's actually better. Oops.
Just put it up on number 19.
Yeah, it should be good. All right. 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to have to make these smaller, aren't I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I've got enough in there, don't I? Oh, I got to go 9, don't I? 1, 2, 3, 4, 5, 6. What did I do? How
You
many?
did 7 at the bottom.
Oh, I did 7 at the bottom? Okay, 8, 9. That's all I got to know. That's all I have to go, right? Okay. So let's plot these. What color have we been using? Orange. So 6, 7. So 1, 2, 3, 4, 5, 6, 7, and then I mean, why do I keep doing that? That's 6. I'm going up 7, right? 1, 2, 3, 4, 5, 6, 7. About right there, something like that. So that's X, and then Y is 9, 11. So that would be right there. and that's y. And we're going from x to y, correct? So we're going in that direction, just like that. All right, and that's what we're trying to find. So the magnitude's pretty easy. Let's do the magnitude real quick. So the magnitude, I'll put m for magnitude. I'll just put mag. All right, so the magnitude is what? It's a distance formula, correct? Now, if you wanted to, because you'll probably need this anyway, if it helps, you might want to do that. Wouldn't you agree? So how far over is it from here to here? 9 minus 6, right? That's 3. How far over it is here? 11 minus 7 is what? 4. Watch the math. Don't even use the distance formula, right? I mean, you could if you wanted to, but what? Watch. 3, 4, what? 5. So the magnitude is 5. That's all there is to that. That was easy, wasn't it? And now you just have to find the direction. Look how easy this one. This was number 19. It was the last one, but it's actually one of the easier ones of this type. Would you agree? Because look, this is going in the direction of the first quadrant. So I don't have to like add a 180 or subtract it from 270 or do any of that stuff, do I? Because it's already going up there. So I don't even really have to put an x and y axis here on this particular one, do I? Because this is exactly what I want to find. And what can I use? Well, I know this, so I can actually use any trig function I want. But let's stay consistent. What have we been using, though? The tangent. So let's use that. So it's the tangent of, again, we'll just call it theta, is equal to, what, 4 over 3, right? Opposite over adjacent. Put it in there. So what is the angle on a 3, 4, 5 triangle anyway? That's what we're going to find, isn't it? So the second function, tangent of 4 over 3. And that is 53.1. So that's it. So if you had a 3, 4, 5 triangle, this angle right here is going to be 53.1 degrees. And you could always find this one by doing what? If you wanted to. You don't have to on this, but subtract it from 90, right? Okay? Make sense? So what's that, like 37.9? Is that right? Did I do the math right? Okay. So if you had a 3, 4, 5 triangle, those are your angles on any 3, 4, 5 triangle. Okay, it doesn't matter how big or small. Those are always going to be the angles on any 3, 4, 5 triangle. Even if it was like 6, 8, 10, that's going to be the angles on it. You with me on that? Okay. Does that help a little bit? 36, sorry. Oh yeah, that's right. Forgot to borrow. 36.9, sorry. All right. Anything else on this? I think that helped, didn't it? A little bit. All right. What about the? Why don't you try the one? Why don't you try that one on the worksheet I gave you? Like number 19. Try that. See how you do. All right. Now it's kind of fresh in your mind. It's always good to do a problem right after you just learned it, don't you think? Yep. So go ahead and try it. I'll give you a couple minutes. See if you can get the right answer. I mean, you got all the answers. I gave you the answers to it, but don't just write down the answer. Number 19 on the worksheet. You got it? Oh, yes. Yeah, on the worksheet. Give it a shot. All right, let's, I've got it kind of sketched out right here, so let's just kind of work on it together. Here we go. I always like to find the sides of the triangle first. It's a little easier, especially when we're trying to find the angle. And so from here to here, the x is like 8 minus 1. What would that be? It'd be 7, right? And this would be 8 minus negative 3 is 8 plus 3, which would be 11, right? So that's 7 and that's 11. And to find the magnitude, you just do Pythagorean theorem and you get whatever you get. And what was that? What did you get for that? Square root of what? 170? Square root of 170? Okay. That's all right. We'll put the square root of 170 in here. All right, so there's your magnitude. Now we want to find the direction, correct? But look what we want to do. We start here. This is our starting point. So we need to start from the positive x-axis and go around, don't we? All right, so I always like to draw that in there. I think it makes it much easier. So watch. I like to put an axis here and an axis right there. It just gives me a place to start from. You know what I mean? So I'm going to start from here, and I want to find that angle right there. See that blue one? That's the angle I'm trying to find. But what am I going to do here in my triangle? You could do a couple things. You could find this angle right here, couldn't you? And take it away from 270. Or you could find this angle right here, which is the same as this angle, right? So, yeah, so you could find this angle, and it's going to be this angle right here. But once you find this angle, or this one, which is the same thing, just add 180 to it. Right, so you got a couple options on how to do this. It is pretty easy, isn't it? So now what do? You take the tangent of that angle, and it's equal to the opposite over the adjacent. 11 over 7, put it in the calculator, and you got this angle. Add 180 to it, and that should be your answer. Seems so much easier now, doesn't it? Yeah. And it's always more difficult when you first learn something, but after you get used to it, then you can see it's not so bad. Yes?
Can you do number 6 really quickly?
All right, let me do this one. 11 over 7. 57.5, right? So that's 57.5, and that's 57.5 right there. But to find the whole entire angle, this thing right here, what do you have to do to it? You're going to have to add 180, right? From here all the way to here is 180, plus this right here, which is 57.5. So you have to go 180 plus 57.5, and that's a 5, and that's a 7, and that's a 3, and that's a 2. Is that it? All right, so 237 degrees. Is that the answer they gave? Did they leave it square to 170, or did they write it both ways, a decimal and that? Nobody's looking? Square root 170? Okay, thank you. 13. Did they just say 13.0? They just say 13? Yeah. Yeah, because it's 13.03. Even if rounded one decimal place, it's still 0, isn't it? So it's approximately 13.0. We good? All right, which one are you asking about? Number 6? All right. On the worksheet, right? Yeah. What kind of figure is this? It's a square. Oops. Try a different thing. There we go. And how do you know it's a square? Just because it looks like one? Right, it's got all the tick marks and it has a right angle right there. So that tells you that that thing is a square, and this is a diagonal of the square, correct? Well, what are you trying to find? You're trying to find x, which is this thing right here, okay? Or any of the sides, right? Find any of the sides. Find that one. Find that one. It's the same exact thing. You could do this a couple ways, but watch. Do it like this. What kind of a triangle is this? It's an isosceles right triangle, which means it's a what kind? Angle-wise. 45, 45, 90, isn't it? Okay, so that's 45 degrees, and that's 45 degrees. So basically, in one little step, you should be able to figure out what this side is. Do you remember the relationship? That the hypotenuse is equal to the square root of what? 2 times one of the legs. We'll just put x there for the leg. So if I want to solve for x, what do I have to do? Divided by the square root of 2. That's right. So this is just 22 divided by the square root of 2. Plug it in a calculator, you're done. Now, if I ask for an exact answer, which, listen, they don't say this on here, but on the test, there are a couple problems where I say find the exact answer. So what if I ask for the exact answer here?
I don't get, like, I got that, but I don't get how you get 11 square root of that.
I'll show you. Okay, I'll show you why. Look, because of this. I divided by square root of 2 because of this. I solve for x. In order to get rid of x, or sorry, in order to get x by itself, you have to divide by the square root of 2. So the hypotenuse is 22 divided by the square root of 2. Now, you got to get rid of the square root of 2 in the denominator, correct? So you multiply top and bottom by square root of 2. So what do you get? You get 22 square root of 2 over what? 2. 2 goes into 22 11 times. There it is. It's 11 square root of 2. It's the best way to do that. Yeah, I said there's nothing wrong with this problem being on the test. Absolutely, this could be on the test. What's that? That's an exact answer. That right there is an exact answer. That's not an exact answer. That's my whole point. You gotta listen. If you put this into a calculator, what is a calculator going to give you? It's going to give you all these decimals after it. Is that an exact answer and you got a ton of decimals after it? No, it's an approximation. I do not, listen to me, I do not want an approximation for a lot of these problems. And it'll tell you. Now, there are times if it doesn't say, write it as an exact answer, you can put it into a calculator and get a decimal approximation. But if it says, write your answer as an exact answer, this is what I'm talking about right here. Everybody understand that? All right, so that's the best way to do that. If you decide to go, do like cosine or something like that, what's that going to give you? It's approximation, all right? So don't go that route with this, okay? You've got to understand it's 45, 45, and you can do that. Or you could have done this. You could have just done Pythagorean theorem, couldn't you? Okay, watch. You could have gone x squared plus x squared equals 22 squared, right? So what is this? This is 2 x squared equals 22 squared. Divide by 2, divide by 2. Then you get some crazy old number. Yeah, I guess you could do it. I mean, there's a couple ways you could do it at this point. You could go 22 squared divided by 2, couldn't you? And that's 242. That's going to be a lot harder. Then you got to square root that. Then you got to simplify it. But you could do that if you wanted to. Yeah, let's see. 2 goes into this 121 times, right? So 2 times 121. Okay. Right? So you could have done that. Square root of 121 is 11. Square root of 2. Look at that. Just get the same exact answer, don't you? Which way did you like better? I know what way I like better. I like the 45, 45, 90 much better, didn't you? It was a lot less work.
Excuse the interruption.
A lot
if I
less
could
work.
ask you to please
So that's what I would do.
dismiss the softball team, girls softball team at this time.
Okay.
Also, after
So
the
be
bell
ready.
rings, if we could dismiss